right, this is video 2 for College Algebra, and today we're going over types of equations. All right, so this is all a lot of review, just kind of getting our minds back into College Algebra and math brain. So first of all, any point on the graph line is called a solution to the equation. So all these equations have solutions. If you can graph it, it's a solution. So the next part is, what are the following points a solution? So here's our equation. To figure out if it's a solution or not, we plug in the point, okay? Remember, this is x and then y, okay? So we've got 13 equals 10 times 2 minus 7, and that would be 13 equals 13. So yes, that is a solution. Okay, our next one, -1, -3. So we'd have a -3 equals 10 times -1 minus 7. That would give us -3 equals -17, which is not true. So this is not a solution, no. All right, when we have equations, we can write our tables and graphs from them, okay? An easy way that we could start this is either 1, by plugging in numbers, or 2, by finding our y-intercept and then finding our slope from there. Okay, so we know our y-intercept is 3 because of that +3, and then my -3 means I'm going to be subtracting 3 every time. So at 1, it's going to be 0. If I move backwards, at -1, we would be at 6. Okay, and again, you can always look at your graphing calculator or Desmos to help you find that table. But always you can plug in x values into your equation and find your y values. Okay, now we can go ahead and plot our points. So my y-intercept is right here at 0, 3. At -1, we are at 6, and at 1, we are at 0. All right. Okay, talking about intercepts. Remember, those are where a point where the graph intersects or it touches the x-axis or the y-axis. So we can have y-intercepts, x-intercepts. These are just some pictures of what this could look like. We would have a y-intercept. A graph that looks like this has 3 different intercepts, 2 x-intercepts and 1 y-intercept. Okay, and then we could of course have something that has no intercepts, like a circle. Never going to intersect any of the axes. All right. Here we're just looking and finding what are the intercepts of this graph. Okay, so first of all, x-intercept, we're looking at on the x-axis. So this would be -2 and 1. So those would be those 2 points right there. Our y-intercept, we're going to go up, and it looks like it's at 3. Okay, you can write your intercepts like this. You could write them as an ordered pair. It doesn't matter. Lots of times on online homework, it'll tell you how to write it. If it just asks for the intercepts, just put the numbers. If it asks for the ordered pairs, then obviously write those. All right, types of symmetry, okay? We can have x-axis symmetry, where it's a mirror over the x-axis. Okay, and we'll label that for you. Okay, if you had a point x, y, that's going to change to x -y. Okay, so even without a graph, you could find these symmetries. Y-axis symmetry is just the opposite. Your point x, y is going to change to -x, y. And we deal with y-axis symmetry a lot, mostly because we deal with a lot of quadratics. And so that's what we'll be looking at a lot. And then finally, we've got origin symmetry. This one's a little strange, but but we do see these types of functions a lot. And our point xy changes to negative x, negative y. Okay, and you're not going to be asked a lot probably to see these, but it's just kind of nice to know them and be familiar with them. Okay, finally, we're going to be looking at circles. Okay, here's our formula for circles. You've probably seen that in geometry, probably maybe a little bit in Algebra 1. And then we're going to find a circle that's centered at this point, negative 1, 2, but it also passes through the point 3, 4. So first, let's go ahead and let's just write in all the things that we do know. All right. So first of all, we know our center. It's going to be x plus 1 squared because this is a negative, so we're going to make it positive. And then y minus 2 squared. Okay, now we don't quite know what it's going to equal yet because we don't know our distance. Okay, and that's where our distance formula comes in. So let's plug in our points for our distance formula. So let's call this r equals the square root of, and we're going to add we've got 3 plus 1 squared plus 4 minus 2 squared. So we've got the square root of 16 plus 4, which is the square root of 20. And that's what equals r. But if you guys remember, in our formula, we want r squared, so we actually just need 20. Okay, so we use that distance formula to help us find our radius. All right. Okay, so this is just our diving into our content of College Algebra, looking at types of equations and just their basics.